Good afternoon friends, this is my another video. If you have seen my previous videos which is relating to velocity analysis of a link, and this is an extension of the part 2 of the second video where we should be doing a bit complex formulations and we should solve it. Now see, the figure is drawn over here. If you can see, the figure is drawn over here. Here a link is there where the RPM omega is given to it or the n is provided. So the link is moving in a circular motion. So as the link moves, it causes the link AB to move like this, the slot to move like this, and from this, with the help of this, the piston moves to and fro. Now that means ultimately this RPM, that is this movement, is converted. It is a rotational movement of the system is converted to a linear motion of the piston. The rotational motion of this crank or the link is converted into a linear motion of the piston. Now you have been asked, suppose you have been given all the dimensions of OA. You are given all the dimensions of OA, AB, BC, CD, and this length is immaterial. So this length is not required right now. So this length is immaterial. So how far the piston is immaterial. So these all dimensions are given to you, and from this only regarding this only the rad is provided. From here you have been asked to find out the velocity of E with respect to G. You are required to find out the linear velocity of E with respect to G, or the velocity of piston, or the velocity of piston, or the velocity of piston. So now how you should proceed to solve the problem? Now first we should find out what are the fixed links over here. So from this figure we could see the fixed links are O, the fixed points are O, C and G. So these are the fixed points. So now we take a point, which will represent O, which will represent C, and which will represent G. Okay, now these points are taken. Now this point will represent point O, C and G, all the fixed points, as we have discussed in our previous lecture. Now we find out first velocity of A with respect to O. As we have discussed that velocity of A with respect to O, we can easily find out because omega is known to it. We can find out the value of omega, that is 2 pi n from the n given to you, and we could find out OA, or the length of this link. So we can easily get the value of velocity of A with respect to O. So now we know that all the velocities as discussed in the previous article, it should be perpendicular to the link. So this is a perpendicular factor. So this is called velocity of A with respect to O. So perpendicular to this. So this link is known both in magnitude and direction. So now we just shift it with the help of a set square. We should just shift the vector from here to here. So now, this should be parallel. This should be almost parallel. So I think with the help of a set squaring, just shift it, and this should be parallel like this. So this is a vector, this is a known vector, that is velocity of A, with respect to O. Now this becomes a point A. Okay, this becomes a point A. So this point, it becomes this point. Now from this we will find out this is the velocity of A with respect to O. Now we see that as this link moves in this direction, so it is another link is connected B over here. So if it moves like this, the B will move like this. If you try to imagine, if it moves like this, then B will move like this. For that reason, velocity of B with respect to A, that is velocity of B with respect to A, should be perpendicular to this. So that is called velocity of B with respect to A. So that is velocity of B with respect to A. Again, we should shift this vector from here to here, perpendicular to this. So velocity of B with respect to A, we should shift it perpendicularly. Velocity of B with respect to here. Now here the same problem, we does not know its magnitude. For that reason we cannot put the end mark over here. So we just draw it. Velocity of A, this is velocity of B with respect to A. This is velocity of B with respect to A should be in this direction. So it comes like this. It comes straight like this. Now what happens? This is velocity of A with respect, velocity of B with respect to A. Now B is a connective point, that is in which AB and BC both are connected. If you see that it is a connecting point over AB and CB both are connected. So velocity of, we have find out velocity of B with respect to A. Now we should see what is the velocity of B with respect to C. We have calculated, we haven't calculated, we have find out the direction of velocity of B with respect to A, which is in this direction. Now we should see velocity of B with respect to C. Now as this link moves like this, as this link moves like this, so this structure will move like this. This BCD structure will move like this. This BCD structure will move like this. So velocity of B with respect to C should be in this direction, perpendicular to this direction. Perpendicular to this direction, that is velocity of B with respect to C. Now velocity of B with respect to C, now this is my fixed point. So velocity of B with respect to C, we know this is a perpendicular, we should just we shift parallelly and we get this point. And we should get this point. So this point is marked our B, which is called the velocity of B with respect to C and the velocity of B with respect to A. So this is our point B. Now we have find out this point. Now an important thing is that this component BCD, this structure BCD is an integral part. So if we see that the velocity of C with respect to B, now if you see that velocity of C with respect to B and velocity of D with respect to C have to be the same. Velocity of B with respect to C and velocity of D with respect to same must have a, not same, but basically should be proportionate. For that reason we have written like this: velocity of C with respect to B, velocity of C with respect to D, and by velocity of C with respect to B is equals to CD, this length, by BC, this length. So now over here, what are the factors known to it? CD is known, as I have told, all the dimensions are known. CD is known, BC is known, and velocity of C with respect to B we can find out from the scale. So all these factors are known. Only unknown, this is an unknown factor. So we can easily find out the velocity of C with respect to D from this proportionality. Now once we get the velocity of C with respect to D, now we can get the value of the magnitude. Now we have to find out what is the sense, in which sense the velocity of C with respect to D will act. Obviously it will act in this direction, perpendicular to this, so it should be like this. That is velocity of D with respect to C. Velocity of D with respect to C. Now we put this over here, which is our fixed point. Our fixed point is C. So velocity of D with respect to D, C should be this point. So this is a known vector, both magnitude and direction. We have the direction we have seen right from here, and magnitude we have calculated from the proportionality. So this will be velocity of D with respect to C. Now we could see that. So as this link moves like this, so it will give a force of the piston like this. So as it moves like this, if you see, as it moves like this, the piston is connected. The piston will move like this. The piston will come like this. If it moves like this, the piston will come. It will pull the piston. Will pull the piston, and the piston will move like this, and will give a reaction force. So this reaction and will give up. The piston will move like this. So when the piston will move like this, so velocity of, we will find out, this is perpendicular. So velocity of E with respect to D, velocity of E with respect to D. So this is our known point D. We have find out the value of D. This is because a known vector. So velocity of E with respect to D, we have found out the value of D. So we should just shift the vector, but we doesn't know its magnitude. The velocity of E with respect to D should be like this. Now to see that as we move like this, the piston will move in this direction. The piston will move linearly in this direction. So when the piston moves linearly in this direction, because as the link gives this force, because of this housing, the piston cannot move downwards. So there is one option, the piston have to move linearly. So because of this, the velocity of E with respect to G, the piston will move inwards, this direction. So we should just draw a parallel to it. So this becomes our point. We could get the value of velocity of, this is called the velocity of E with respect to D, and this is called the velocity of D, velocity of E with respect to D. We have, sorry, this is velocity of E with respect to D, and this is velocity of E with respect to G. This component is the velocity of the linear velocity of the piston. So ultimately this is our point, this is our focus. We could find out the value, we should find out with the help of a scale, we should calculate this value. And suppose we have taken what I have discussed in the previous slide, if 5 meter per second represents 5 centimeter, or 1 meter per second represents 1 centimeter, and if this comes to about 50 centimeter like that, we should convert it back to meter per second, and we should get this value of the velocity of piston, which is the linear velocity. So ultimately n is given to that, and with the help of a velocity diagram we should calculate the linear velocity of the piston. Okay, so that's all about. If you again, one thing, if you like my way of teaching, so kindly put a thumb mark, and please subscribe my channel. Thank you. Good.